Hello, welcome to today's math class. Today we have a very nice math problem before us here. The question is the cube root of x plus the cube root of y equal to the cube root of 2024. What year are we into? We are into the year 2024. So we want to create a math challenge that has to do with the year 2024. So how do we get the value of x and y that when we put together the cube root of them, that will give us this? So if you've not subscribed, this is Math Prowess. Subscribe, and when you subscribe, turn on the notification bell so that you get notified whenever we release an amazing video, because at Math Prowess we release nice video all the time. So let's take today's challenge by taking our solution. All right, again, the question again from this expression, let's rewrite this side of the equation, the quantity we have here. Okay, so we're going to break down this. And how do we break this down? Let's drop sign here. So we have 2024 here, right? Then we use 2 to divide. 2 here will give us 1. 2 into 0 will give us 0. 2 into 2 will give us 1. 2 here will give us 2. What can go again? 2 can equally go into this. So 2 into 10 will give us 5. The 2 into 1 cannot. So we have 0. 2 into 12 will give us 6. Right? 2 can equally go again. So 2 here will give us 2. 2 into 10 will give us 5. And 2 into 6 will give us 3. So 2 cannot go again. In other words, we can rewrite this side of the equation as 8 times 253. So let's go ahead and rewrite this. So we're going to have here the cube root of x plus the cube root of y equal to the cube root of 8 times 2, 5, 3. Let's cover this, all right? Okay, so from this, we know the cube root of 8 is 2. So we now have this to be the cube root of x plus the cube root of y equal to 2 into the cube root of 2, 5, 3. Close bracket. From here, we do some crazy substitution. Okay, so yeah, we cannot say here let. Okay, so say let's take first x. Let x be equal to 2, 5, 3. Let's use a t to the power of 3. And again, then we use y. We say let y be equal to, this time let's take 2, 5, 3 p to the power of 3. So wherever we see our x, let's put this, and wherever we see y, we put this. So we cannot have this to be the cube root of our 2, 5, 3 t to the power of 3 there, plus the cube root of 2, 5, 3 p to the power of 3, everything equal to 2 into the cube root of 2, 5, 3. Okay, so what do we do next here? So from here, we can bring out p here, because the cube root sign here, we cancel this. So rewriting this expression, we're going to come up with our t, okay, bracket the cube root of 2, 5, 3, close bracket, there, plus p was a come out here. Then we have the cube root of 2, 5, 3, close bracket, equal to 2 into the cube root of 2, 5, 3. Right? Okay. Now, if we look carefully here, we observe something. What is common to this quantity now? We can bring out cube root of 253 because it's common here, right? So if we do that, we're going to have this as the cube root of 253, right? Close bracket. The into here will be left with t, because if we use this to divide this, we have t. We use this to divide this, we're coming up with our p, close bracket, equal to, then we have our 2 into the cube root of 253, close bracket. So if we divide through, then this will leave. So when I have t plus p is equal to 2. Easy. So at this point, we have to do some manipulation. So we roll up here. We have here to be our t and here our p. So what will be the two quantity? Because here we're looking for the real root, the integer value of p and t. And so if t is 0, what will be the value of p that will give everything to be 2? So we're going to have 0 and here we have 2. Then if this one increases to 1, then this will also be 1. And if this increases to 2, then this will be. So at this point, we have our t equals to p in this expression. So what does that implies? So it does means that our p is equal to 1 and our t is equal to 1 also. So if we have this established, then what happened? So from here, we recall what we said, let x be equal to this and y be equal to this. So let's substitute and see what this gives us. So this now implies that our x equal to 2, 5, 3 t to the power of 3 will now be equal to 2, 5, 3 times 1 to the power of 3, which automatically will give us 2, 5, 3. That's our x. Same thing, our p, we said, y rather, we said our y is equal to 2, 5, 3, p to the power of 3. And we've also said p is equal to 1. So we're going to have here 2, 5, 3 times 1 to the power of 3, which is equal to 2, 5, 3. Okay, so therefore, we now have our x, comma, y will now be equal to, let me bracket this way, will now be equal to 2, 5, 3, comma, 2, 5, 3. All right, so this is the values of x and y that will satisfy these our radical equation. Now, I want to do a little check. So let's check if this actually satisfies the equation. So check. Here we have our question to be the cube root of x, then plus the cube root of y, then everything equal to the cube root of 2024 rather. Okay, so if we substitute, we're going to have this to be the cube root of 253 plus the cube root of 253 equal to 3, which is our cube root of 2024. All right, so according to the law of sword, we can add these two together. So this will now give us 2 into the cube root of 2, 5, 3 equal to the cube root, right, of 2024. Okay, now if we shift in these two inside this cube root, that will be 8. Remember? And 8 times 253, that will give us 2024. So automatically, we're going to have this to be the cube root of 2024 is equal to the cube root of 2024. So this shows that the answer, this, satisfies the original equation here. All right. So thank you for being there. Bye for now.